Today you'll be learning about simplifying radicals, and we've been talking about square roots, and that's all it is, radicals. One of the key things with the radicals when you're simplifying is to know that the square root of a number can be broken down into the products of that number. So for example, if I have the square root of 16, I can break that down into the square root of 4 and the square root of 4. So the square root of 4 is 2, and once you can get a perfect square, it pops out. And the square root of 4 is 2. So that equals 4, and therefore the square root of 16 is 4. Let's do a few examples, and I use kind of like factor trees when I do this. So I do square root of 12, and I want to simplify that. So I go, okay, I know that square root of 4 times the square root of 3 would give me 12. Now I look for a perfect square, and I get one right here, so it's a 2, so it pops out of the square root. I can't go any further with the square root of 3. It's not a perfect square. So the answer to this one is 2 square root of 3. You just stop if you don't have a perfect square. Okay, with 180, let's break that down. So examples could be, let's say I started with, I'm going to start with 20 and 9, because 9 is a perfect square. I'm going to leave that perfect square there, and I'm going to break down my 20. So square root of 4, square root of 5. I have a perfect square. So the square root of 9 is 3. The square root of 4 is 2. I take those ones that I popped out of the square root, so 2 times 3, and I get 6. And then whatever is left over on the end branches, so square root of 5, I just stick it right next to it. We could find out what the square root of 5 is by using a calculator, but we're not going to right now. Let's try 75 square root. So the square root of 75, I'll do 25 and 3. 25 is a perfect square. So I know that's 5. Can't go any further with 3, so I put 5 square root of 3. Okay, now you have the square root of 63. So I know that 9 times 7 is 63. The square root of 9 is 3, and then 7 you can't go any further with. So 3 square root 7. Let's look at some more examples. Okay, we're going to look at some division examples now. So if you do the square root of a fraction, which is really a division problem, you can do the square root on top and the square root on bottom. You can't have a square root on the bottom, and I'll show you how to get rid of that when we go through this. Okay, so this is really the square root of 32 over the square root of 50. So I'm going to do my little factor trees over here. And I'm going to go, okay, 32 is 16 and 2, I know that. So the square root of 16 is 4, and I have square root 2. So on top I'm going to have 4 square root 2. Let's do 50. I know 25 and 2. 25 would be 5, and you can't do anything with 2, so you go 5 square root 2. If you have the same thing on top and the same thing on bottom and it's being multiplied, you can cancel them out to give you 1. So really this is 4/5. Let's look at example 18. So I'm going to do the square root of 1 over the square root of 18. I can break 1. 1 actually pops out to be a nice perfect square. Square root of 18 breaks down into 9 and 2, which gives me 3 square root 2, because this is a perfect square. So 3 square root 2, and remember what I said up here, you can't have a square root on the bottom because it makes it irrational. So in order to get rid of that, you're going to multiply the bottom by that same square root, and whatever you do to the bottom of a fraction, you have to do to the top. So on top I'm going to have 1 times the square root of 2, which gives me the square root of 2. And then if I do the square root of 2 times the square root of 2, that gives me the square root of 4. Square root of 4 is 2, right? So what's 2 times 3? 6. And we're done. We can't reduce this, the 2/6, because it's under a square root. If it weren't under a square root, I could reduce it. Okay, let's look at a little more complicated one. You have this negative 4 out here. Leave it until the end. Let's just deal with our fraction. Square root of 1 and the square root of 10. So I have 1, and this can only break down into 5 and 2, and that doesn't give you perfect square roots. So you leave it as square root of 10, but remember, you can't have a square root on the bottom. So you multiply it by square root 10, square root 10. On top, I'm going to get square root of 10. On bottom, the square root of 10 times the square root of 10 is the square root of 100, which gives me 10. So I have a 10 on the bottom. Now I'm going to take that 4, negative 4, over here, put it over 1, and multiply it by square root 10 over 10. So I get negative 4 square root 10 all over 10. I can't multiply the negative 4 by the 10 inside because it's in a square root, and I can't divide the 10 and the 10, but I can reduce the 4 and the 10. 2 can go into both of those, so I'm going to get 2/5. So your final answer for that would be negative 2 square root 10 all over 5. And that's it for tonight. I missed you guys. Talk to you later.